Hey everyone, in this one we're looking at expanding. We'll do factorizing in another video. So we're just going to be expanding our algebraic expressions, and we are also going to look at what happens when you have perfect squares. So expanding is the process of removing the brackets from your equation. You do that by multiplying terms. This is very familiar to those that remember Oprah Winfrey or the distributive law, as we most likely would. That is what you're doing, but there's lots of ways to remember it. So if you had x times 3x plus 1 gives us 3x squared, because that's x times x, times 3 plus x. So that is expanding using brackets. And then we're now going to look at also binomial expansion. So that's when you have x plus 1 and x plus 2, and what happens when you have those situations. So as a reminder, here is a visual diagram of it. So this is your factorized form. That's why we kind of link them with this, but we are trying to get it into this format, and that's what we'll be looking at in a moment. Let's start with just when you have one term out the front, or a situation like what we call the Oprah Winfrey kind of situation. So simplify the following expressions. Just don't be rude. Say hello. So everyone gets a 2. Times this by 2, times this by 2. We're simplifying by expanding those brackets and removing them. So 2 times x equals 2x plus 6. 2 times 3. This one here. Remember, invisible maths, there is a 1 in front of that. So that's negative 1 times x gives us negative x. And negative 1 times, so if you ever get stuck, start with the multiplication only. 1 times 3 is 3. Negative times a positive, negative. So that's your answer. Or your simplified expression. Now when you have both terms, remember it's still, everyone says hello. So this is a term multiplied by this term. You were saying 3x times 5x. 3 times 5 is 15, and x times x is x squared. Then this one here comes 6x, negative and a positive, negative. Again, I'm just doing the arrows underneath just because I don't have enough space here. 2 times 2 is 4, x, so this would be your index laws. It's x squared times x, which is invisible maths. There's a 1 here. Add your indices together, that's x to the power of 3. X to the power of 3, and then this one here, 2 times 3 is 6. X squared, positive, negative, multiply together gives us a negative. So, pause the video, put these in your homework booklet, and have a go of those. Right, let's see what happens when you are expanding with two terms, when there are two sets of brackets. So what we're going to be doing here is, this is the visual explanation of it. If this was a plus b, there it is there, so I'll move it down so you can see the whole thing. If we think back to a rectangle, the area of a rectangle is length times width. Now in this case here, it's a times c, and as a result you get AC. Now if you did the same thing with this area, it would become BC, DA. But this is the part that everyone forgets about, is that you also, to complete the square or the rectangle, you need to have this area as well, so BD. So again, we're expanding, simplifying. It's called FOIL by some, German handshake by another. It's very similar to the Oprah Winfrey, a square, because you're arranging it like this. Whatever it is, take your pick. You are distributing your terms and therefore expanding your brackets and removing them. So that's essentially the mathematics that you're doing. Each of these, if you start to do enough of them, you'll start to see that there's a pattern occurring, especially with this one and this one. So let's have a look first when you have your these two terms. So I might use this one here, FOIL, so we can do our first. That's what FOIL stands for. It's first, outers, inners, and last. So you do the first equals x squared, then the outers, so that looks like ULA. Outers are 4x, negative times positive, negative. Inners, 3x, positive times positive. And then the last terms, 3 times 4 is 12, positive, negative, negative. Collect like terms, x squared is not the same as these ones. It's a supercharged x, whereas these are standard issue 7x's altogether. Minus 7 as minus 12. And then that is your answer there, or your simplified, expanded and simplified. Again, you might want to call this Oprah Winfrey, so everyone here has to be given to everyone over here. That's essentially what's going on. So you get an x, and you get an x, and you get a 7, and you get a 7. Negative 7, sorry. Same concept. So x squared plus 2x minus 7x. Oh, that is a negative. 7 times 2 is 14. Collecting like terms. Now, if you're ever unsure, just get the calculator out and check. But it's 2 minus 7. So that's going to give us negative 5 minus 14. This one here, this is what we call, I'm going to write it over here, dots. This stands for difference of two squares. And you'll see what the pattern is in a moment. So x times x, x squared, minus x, plus x, minus 1. Now if you have a look here, if I'm on my number line, negative 1, plus 1, so going this way, I end up on 0. These two, we don't write x squared plus 0 minus 1. That has no impact on the equation, but you'll see that it's x squared minus 1. Now if this was also, say, x minus 3, x plus 3, x squared, 3x plus 3x minus 9, x squared minus 9. If you did enough of these, you'll eventually find that the pattern is x squared minus the square root of the second number. And that gives you, that's why it's called the difference, because you're subtracting of two squares, because that is the squaring of something when you multiply it by itself. If you have a look at this one here, is what we call perfect squares. So we'll talk about this one here. This is the same as writing x plus 4 times x plus 4. Treating it like any other one, x times x is x squared, x times 4 plus 4x plus 4x plus 16, because 4 times 4 is 16. X squared plus 8x equals, oh, too excited there, Control Z, and plus 16. This is what we call perfect squares. So when you have a multiplication, an addition, and it's been squared, you double this number, because you're having two lots of it, and you square it, and then that results in this pattern here. So you can use that as your shortcut, but you've got to kind of start to do a few of them before you kind of recognize that pattern. And it's the same with the difference of squares. You start to do enough of them, you'll find that you might skip this step and go straight to here, or straight to here. All right, so having a look here, we have back to our other color. Oh, sorry. So writing that out, I'm just going to put it onto here just because I haven't given myself much space. So x squared, 3x 3x, and this becomes positive 6. X squared minus 3, negative 3 minus 3 gives us negative 6x plus 6. If you start to see this, you'll know that there's a hint there. This is a result of double negatives. So I'll leave that as a clue. Now what happens when you have something like this? It doesn't look quite the same, does it? So 2x minus 2. It's been squared, so 2x minus 2. And as a result, we have still the same thing. 2 times 2 is 4. X times x is x squared. Minus 4x minus 4x plus 4. So many 4s. And plus 4. And that is your collected of like terms and simplified it and expanded. So pause the video, have a go of those questions there. Alright, stay awesome.